Let's write the balanced net ionic equation for ammonium oxalate plus aluminum perchlorate. So this one's a bit involved. First thing we need to do with net ionic equations, we need to balance the molecular equation. This is the molecular equation. As I look at it, I can see that I have an oxalate ion here, and then I have three of them over here. So I'm going to balance that first because that's going to be a fairly large number. So if I put a 3 in front of my ammonium oxalate, I have 3 oxalates. Those are balanced. But now I have 2 ammonium ions times 3, 6. I'm going to put a 6 in front of the ammonium perchlorate. The ammonium ions are balanced. I have 6 perchlorates and only 3 here. If I put a 2 in front of the aluminum perchlorate, I have 2 times the 3, 6 perchlorate ions. Those are balanced. 2 aluminums over here, 2 aluminums. That's the balanced molecular equation. That's a lot of work. Now we can write the state for each substance, and that looks like this. So compounds with the ammonium ion are very soluble. So these compounds are soluble, and in general, the perchlorate ion very soluble as well. So we have these are all soluble, but this aluminum oxalate here is insoluble. So this is going to be a precipitate. It's going to fall to the bottom of the test tube when these substances react. So we have our states. Now we can split the strong electrolytes into ions for the complete ionic equation. And we don't split solids apart in net ionic equation. That'll look like this. Note that when we look at the complete ionic equation, we have these 2 ammonium ions here times 3. 2 times 3, that's why we have 6. We have 3 times the 1 oxalate. That's why we have 3 of these oxalate ions here. So you have to pay attention to the coefficients and then any subscripts outside parentheses. Now we can cross out spectator ions. They're on both sides of the complete ionic equation. So in the reactants, 6 ammonium ions. Again in the product, 6 ammonium ions. Spectator ions, we cross those out. Here we have 6 perchlorate anions and 6 perchlorate anions. Cross those out. What we end up with is the net ionic equation for ammonium oxalate plus aluminum perchlorate. I'll clean this up, write the states. We'll have our net ionic equation. So this is the balanced net ionic equation for this NH4 C2O4 plus AlClO4 ammonium oxalate and aluminum perchlorate. You know, charge is conserved. 2 times 3 plus, that's 6 plus. 3 times 2 minus, 6 minus. That adds up to 0, net charge of 0. And then this is neutral, net charge of 0. Charge is conserved, and if you count the atoms up, they're balanced as well. This is Dr. B. Thanks for watching.